And I'd just like to welcome everyone to the OTF Connect session, the progression of multiplication with Kyle Pierce. It's always great to see people from all over Ontario join us for these fantastic sessions, and I know that you're going to have a great session tonight with Kyle. So I'm just going to go ahead and let him introduce himself, and we'll enjoy a fantastic evening.
Awesome. Thank you so much, Mally. I really appreciate it. And thank you, everybody, for joining me again. It's always great to see some familiar names coming into the room. Hopefully we'll see some more trickle in. We were expecting quite a few more, so hopefully some people are just getting in the door and trying to get themselves organized, sort of like we're doing over here in the Pierce household. So thanks again. Tonight we're going to be exploring some multiplication. We're going to be trying to sort of launch from Matt Oldrich's session last week on counting and addition and subtraction, or composing and decomposing numbers. So really excited to get going. The first thing I might recommend that you at least begin doing, and I can see Claudia and Allison have already done so. In the chat box I had shared some instructions, and I'll share them again, to open up a new tab, or if you have a mobile device probably the best, simply because you do have a camera on your mobile device that's easily accessible. Tonight we're going to be using Knowledge Hook Game Show, which is a free tool, and I'll just change our slide here. A free tool, and by going to khmath.com/play, you're going to be able to put in a game pin, Guru 2447. And we're going to be using this tool throughout the evening. We'll be coming back to the OTF Connect webinar window, as well as going to our phone or a new tab in our web browser to do a little bit of interaction throughout the session. It seems to have worked quite nicely in the past, so we'll try it again now as well. So up on the screen you'll see that code there. And just as a side note for you, when you get there, you're going to be putting in that class code, and then it's going to ask you if you want to create an account or sign in as a guest. So I'm going to recommend signing in as a guest, since you'll likely only be in this in my class, quote unquote class, for one particular evening. If this was a class full of my students, I would probably recommend having them sign up for an account, since once they have an account, I just have to press play, and basically they log in and they'll jump right into the game show room. So it becomes pretty easy, pretty simple. You guys get to click on an avatar and you get to join the room, and then you'll just be waiting for the game show to begin. So I'm not going to click play on this game show yet. I will do so in a few minutes when we get to that point. But again, the main reason why we're using this tool, and this is the main reason why I use it in the classroom, is for this button right here. After you submit an answer, either a multiple choice, open response, whatever you decide, the students then have an opportunity to share their solution by taking a photo of their work. So I'm sure you can understand why it might make sense for a webinar, because you guys are scattered all over the province, and it makes it very difficult to actually do the math and share your thinking without having some sort of visual. So this will allow us to do some of that, and I'll be able to see some of your thinking. And I'm going to try my best to take some screenshots and put them into the browser window. So I might need Mally to remind me how I'll be able to do that once I save the photo, but we'll figure it out as we go. So to get us started here, I thought I would just take a moment to share a little bit about myself and my family. Up on the screen there, you'll see my wife Chantel, my daughter Talia, who you just saw wearing her Woodsley Orioles baseball hat, and my son Landon. They're upstairs, if you can't hear them in the background, doing the night routine, which involves sometimes some stomping around and some begging for additional books, which I suppose isn't such a bad thing. So for those who have joined us before, you'll know that I do have a vision for mathematics education, and it looks kind of like this. I believe that really wherever possible, if we can start with context, if we can make math visual, and if we can start at the concrete and work our way towards the abstract, as well as showing interconnectedness, I feel that students are going to increase their confidence, especially when they get to a guy like me who comes from the secondary panel. So for me, by the time students came to grade 9, oftentimes their confidence was gone. When kids come into school, they're very confident. They're very confident about what they can do, but somewhere along the lines, they sort of lose that confidence, maybe that fear of failure, or just maybe not fully understanding what it is that they're doing in math class. So we want to reverse that and raise that confidence. I think that's going to change our perceptions about mathematics. And then finally, we'll see student achievement increase. So that's going to be kind of down the road. We've got to change a lot of things first before we're going to see that happening. So what we're going to do to get ourselves started, we're going to start with a problem. On your game show screen, what you're going to see is a video that appears similar to what you'll see in the chat window. So if you're not in the game show yet, I see 18 of us in. I'm going to go ahead and click the play button. So on your devices or in that tab, you should see in the next couple seconds the opportunity for you to play a Vimeo video. So I'm going to give you a second to go ahead and watch that video. Once the video is done, I'm going to have you click the button to indicate to me that you are finished, and then we're going to do a notice and wonder. So as you're watching this video, thinking about what you notice and what you wonder. All right, I see about 10 of our 20 logged into Game Show are indicating that they've finished watching the video. Make sure you hit the submit button as well once you click. The submit button might be hidden on your phone. You might have to scroll up a little bit on your device to lock that answer in. And then we'll give you an opportunity to do a notice wonder. Awesome. So it looks like most of our people are in. What I'm going to have you do is I'm going to end this question here, and I'm going to go ahead and let you folks in the chat box in our webinar window, I'm going to have you share something you've noticed, something you wonder. You might have more than one. Feel free. I'll give you a little bit of time here. Let's do about 45 seconds, and then we'll share out. All right, nice to see a couple coming in here. So did the plane take off and leave from the same place? I wonder where the plane was going. How fast? Is it a time-lapse video? Seems faster. I wonder how this video relates to math. That might be something you're thinking about. I've got a rate of speed coming from math. Ooh, flying out to Thailand, lucky you on Monday, so you're getting excited. That's awesome. I'm flying out to Alberta on Saturday morning. Not as excited as going to Thailand, I would imagine. Oh, we see, must be Toronto. How long was the actual flight? I'm having an issue with the space key. That's a problem. I apologize. Well, I can't really apologize, not our fault, but unfortunately I feel bad for you that your space bar is not working. Awesome. So lots of great noticings, lots of great wonders. And in my classroom, I want to engage my students in all of these ideas, and I want to attempt sparking their curiosity a little bit. We noticed it's Billy Bishop Airport. Someone asked where this flight was to, and you are right. It's the same flight when I landed and as well as when I took off, and this was from Windsor. So from Windsor to Billy Bishop. And what I'm going to have you do, I'm going to skip ahead a slide here. You might have to wait just 1 second here because I'm going to skip over question 2 and go straight on to question 3. I'd like you to make a prediction. You're looking at an overhead view of that particular plane, and I want you to make a prediction in your Knowledge Hook screen. How many seats do you believe there are on this plane? So obviously you don't have a ton of information yet, We want to get some numbers out on the screen. How many seats do you think there are? We'll have you lock it into our knowledge hook. If you don't have knowledge hook, you can go ahead and lock it into the webinar chat box. All right, awesome. So I see in our chat box over here, we've got 50, we've got 30, 24. Interesting, interesting. I'd love to get in and pick your brains a bit, and I will in just a moment here. All right, so it looks like most of our answers are, or most of our people are almost in here. All right, we'll give you about 5 more seconds to lock into Knowledge Hook, your answer into Knowledge Hook, and then I'll end that question. We have someone going back on their answers, so we're going down to 30. 30. We have 20, 12. Awesome. I'm going to end this question here. And we've got, oh, look at this. It looks like our highest prediction is 130. Our lowest prediction is 4, a real small plane. Windsor is small, but we do send more than 4. But you never know, right? We never know. We don't know the size of this plane yet. Awesome. Well, here's what I'm going to do. I'm going to send down another question to your device. If it doesn't load, just hit the refresh button. But right now, you should see a partial view of the seating plan on the plane. And I'm only going to care about the passengers here. We're not worried about any flight crew. If you're looking at this image, I want you to make a prediction. How many seats do you believe there are on this plane? If you can update that prediction, that would be awesome. I'm going to show the same view in the webinar screen so that if you aren't in Knowledge Hook for whatever reason, if you couldn't get in, you can see this through the webinar as well. So we should have the same image up on the screen on Knowledge Hook as we do in the webinar. How many seats do you believe there are in total based on what you see here? And that is the entire seating plan that you have in your view. We have just blocked some of it out. We've got Gail and Julie at 16. All right, our Knowledge Hook people, oh, Christine's on 16 as well. Awesome. Our Knowledge Hook people, we only have a few more left. In the chat box over here, I'm wondering, Julie's saying she can't actually enter an answer. That's no fun. If that's the case, just toss it right in the chat window. That has happened to me a few times lately, so I'm not sure why that is. All right. I'm wondering, for those who believe there are 16, if you want to toss into the chat box, why do you believe 16? What's your thinking behind that? And if you believe something different, feel free to toss in your thinking behind that as well. I'm going to end our Knowledge Hook question. I see I've got a range of 16, I've got 18, 20, 24, 80, and 36. I see 18 coming up for Amy and B. Interesting. So we have 6 missing spaces, Gail says. Heather looked at how much space it took up and used some proportional reasoning to estimate the total. Awesome stuff. And something that I really like about problems like this, when we give students this opportunity to predict, well, first of all, when we predicted and you had no idea, you really got to participate without really having any information. So it really makes you feel comfortable that you are taking ultimately a guess. But when I give you a little bit of this information, what you end up getting is a whole lot more use of your visualization. So when we're thinking about spatial reasoning and building those visual skills and that visual ability, what we're doing with these problems is really allowing students to think like that, which is really great. So what I want to do is I'm going to click onto the next question here, and on your Knowledge Hook screen, you should see the following image, which is there are 18 seats total, so that's awesome. In class, I would do a 1, 2, 3 clap for my friends Kathy and I believe who else? B and Amy and a few others had 18 as well. So awesome job on that, doing a little bit of visualizing and a really nice introduction into our session for today. Because when we think about proportional reasoning, when we think about the arrangement of these seats, there's a really particular reason why I selected this particular visual. But before we get there, I want to take a moment just to sort of slide back to Matt's session and talk a little bit about a few of the pieces that he had mentioned about a week ago in his webinar. And really, in particular, I want to talk about some counting principles. I'm not going to go through all of them in particular, but there are a couple that I really do want to have a look at. So if you haven't experienced any or don't have any experience with counting principles, I'm going to put up on the webinar window here. I have 9 listed. Some would argue that I'm missing a few, and I'm starting to believe that I am as well. Some people list 5 main counting principles, but really what we're finding is that this progression is really complicated. And in order to get us to the operation of multiplication, we have to think about our counting principles and how important there are. Some of us might be familiar with things like one-to-one correspondence, but others might be a little bit more difficult to comprehend. So one that I'm going to hop into is this idea of conservation of number. And if we take a look at these candies here, and if I was to go ahead and actually tag these numbers as being a group of 6, conservation is this idea that students know that even if I spread out these candies, that there's still going to be 6, that that's not actually going to be a larger quantity. So all of these different counting principles are really important, but the one I'm going to focus in on today is the idea, it's the last one listed here, it's this idea of unitizing. And the idea of unitizing is looking at groups, equal groups of objects, and calling them a unit. So counting those groups would be unitizing. And in our base 10 system, we are unitizing when we say that we have this many ones and this many tens and this many hundreds. So when I say 326, there are 3 units of 100, 2 units of 10, and 6 units of 1, which is really, really important. And if we want to think multiplicatively, we're really going to have to be proficient with this idea of unitizing. So as I get 10 ones and I get a 1 in my 10 column, eventually we're going to go to symbolic notation, and students are going to see that, you know what, that 1 on the left in that tens place column actually represents 10 ones, and the magnitude is actually 10 times bigger than a 1 in the ones column. Like, this is very, very complex thinking that students must do, and sadly I don't know if they necessarily get the opportunity. I know I didn't when I was younger. I sort of just had to do some, I guess, connection making on my own, and luckily some of it happened organically, but much of it I'm only learning now. So with that said, those counting principles, we're going to take unitizing and we're going to jump in right into multiplication. If you're here from primary and you're really interested on working on some of the counting principles, I do want to share a quick resource with you called Tiny Polka Dots. There'll be a link coming in the chat box in just a moment where you can buy this board game. You can also buy a $5 printable for this game, which is really, I mean, really affordable. It comes in color and you can actually print it off and laminate it. But the beauty of this game is that you start with simple dots, and they have a deck with dice, with the dice configuration, great for subitizing, great for students really building their number fluency. And then as they get better, you start throwing in things like 5 and 10 frames. Students then start working with different patterns. So here we're arranging our dots in circles. Then as we go on, we start looking at this idea of abstraction, where students can work with cards, and it doesn't really matter the size of the dot. It's the number or the quantity that really matters. And then what you see is different colored dots. So this is really going to promote perceptual subitizing, conceptual subitizing, where students are actually looking at these two separate sets of dots, one in blue, one in green, and then in their minds putting them or composing them together. So really good, and then finally seeing some symbolic notation. We're going to come back to this idea of working from concrete, and then in this particular case, this game would be considered visual, and then working towards the abstract, which is symbols. So lots of really cool games in there. Definitely check it out if you're in primary or if you're an administrator and you want to help out your primary teachers. So we're going to take the leap here, and I know that in grade 2 we do a lot of equal grouping and fair sharing and all of these wonderful things that promote the idea of unitizing. Well, in grade 3 we take a leap and we start looking in particular at multiplication. So I'm going to give you an opportunity on your webinar window to give this particular specific expectation a read. And what I want you to think to yourself is, what is the big idea here that we are going to be teaching? And then finally, what are some specific things? And then we'll have you share out, almost like a notice and wonder here. We'll have you share that out in the chat box. So I'll give you about a minute's time to do that. All right, our first share out, a big idea, how multiplication is used in real life. All right. Operational sense, nicely done. Now, as you're sharing this out, oh, we have multiplication and division. And typically what I see is exactly what you're seeing as well. I see a lot of people will look at this expectation, and I would have, for the majority of my career, would have just said, okay, multiplication and division. Something else I might have noted, maybe I wouldn't have, might have been one-digit numbers and division by one-digit divisors. So kind of keeping that in mind is interesting, just so I kind of know the scope of how deep I'm going to go into this concept. But an area that oftentimes I don't think we focus enough on in education is those brackets, those examples of how we might go about this. And I'm going to argue that this isn't just an example like maybe you might do this or this or this. It's actually telling us we really should do these things, and oftentimes in that order. And I'm now starting to see that, you know what, in grade 2 we place objects in equal groups. Well, we're going to continue doing that in grade 3, and at some point we're going to start moving towards this idea of an array. And this is something that I don't think gets enough attention in it gets a lot of attention in the curriculum, but I don't think we give it enough attention in the classroom. The word array comes up, I believe, around 10 times in the Ontario grade 1 to grade 8 Ontario math curriculum. And then it actually grows and transforms into something else that we'll look at a little bit more today. So what I want you to do in the chat box, I want you to share with me, what is an array? What is an array? And you might be thinking in math class, but maybe you're thinking about an array like outside of class. Like, what does array mean to you? And then we'll take a look at a simple definition of it, and we'll start playing with the idea. Awesome, seeing a lot of stuff going here. Visuals with columns and rows, organization of items, lots of great sharing out here, using concrete materials, awesome stuff. Being able to solve your math, oh sorry, that was a big idea I believe I just said there again. Awesome, a grid, an open array may look like a rectangle. Awesome stuff, so lots of great thinking here. If I go to Google, this is what Google says an array is, an impressive display. I didn't know it was impressive, but I guess Google thinks it's impressive, of a particular type of thing, ordered arrangement in particular, and ordering things in a particular way. Now, if we get more specific and we talk about a multiplication array, what you're going to see is Google showing us an example using these triangles. Now you'll notice in the example they pull, computers aren't always the smartest creatures. It's pulled a different image, an image of a 5 by 4 array, yet the example is a 4 by 3, which is interesting. So don't pay any attention to that, but Google does know that a multiplication array actually shows these objects in those rows and columns. So this is really important. So the first thing I would typically have you do, and you're more than welcome if you have objects or if you have a piece of paper and you want to draw along, with some of these more basic ideas, we're not going to do a ton of sharing into the knowledge hub, but when we do get more complicated, we definitely will. So first of all, I want you to think to yourself, what does 3 times 2 actually mean? What does it mean? Why? What are we trying to get students to do? And then I'm going to have you on a piece of paper at home or with manipulatives, if you have them available, we're going to have you create a array. Awesome. We've got 3 groups of 2. I have someone saying 2 groups of 3, 2 rows, 3 columns. Awesome. Lots of different discussion here. That's great. Groups of something. That's awesome. And typically the way I read multiplication is I read from left to right. I read 3 groups of 2 here. And if I see it, even though the result is the same, if I see 2 times 3, then I'm thinking 2 groups of 3. Now, some might want to, argue on that one. I mean, I'm not really willing to get too crazy on that idea. But my feeling, at least how I try to verbalize it, so there's some sort of consistency, is listing my multiplication sign as a symbolic representation of the groups of idea. And it looks like Estelita has a hand up, so I'm wondering if you want to turn your mic on and share something to the group. Okay, maybe not. Maybe she raised her hand by accident. So, okay, but feel free to toss it in the chat box if you do have a question. So again, the wording for me, I really try to stay consistent on that. However, again, while the result is different, I think of how I look at this array, particularly as 3 groups of 2. So if I use an array, and I call this portrait mode, if I have my array in portrait mode, then I'm looking at my groupings horizontally. So I see 2 across, then 2 in the middle, then 2 at the bottom there. I could also go landscape mode, and now I'm looking vertically at those groups of 2. All right, so the idea here is that if I have context, then the way I write my multiplication sentence might matter. All right, and for me it matters. But again, I would argue in the classroom, oftentimes we don't pay too much attention to that. I think we'd all agree that 4 groups of 3 is going to look something like this. The beauty is it doesn't really matter the orientation of your array, but it does matter that we do know how to represent this. All right. Beautiful. Awesome. Great chats going on as well. So here's the next question that I have for you. My next example that I have for you is this idea. If I look at using arrays, not only is it really important for students to play with this idea, but also it helps them with becoming more proficient and more flexible with their numbers. Like, for example, doing skip counting. Oftentimes, students are really good skip counting numbers like 2, sometimes even 3, and oftentimes starting at 0. Right? So just skip counting alone can be really beneficial if we want students to improve their automaticity, like so many people in the media seem to want and so many people in the public want, then we really do need to give students an opportunity to really play with these ideas and build their number sense by doing the actual manipulating. So here's a question I have for you. I'm going to have you respond it in the chat window. What if I modify this particular problem? And we're going to use different numbers, so the numbers don't matter here. But what if I modified my number of rows to be the same as my number of columns? So in other words, if the number of items is the same as the number of groups, what is going to happen to my array? What happens if my number of items in each group and the number of groups is the same? Awesome. So we've got lots of people sharing that out. It's this idea of a square, and I love Anit as saying a perfect square, because this is a concept that I mean, for me, I went through university for mathematics, and honestly, I don't think I ever really thought about what squaring a number looked like. So when I think about this 5 groups of 5, that I can also later on, not in grade 3, we're not going to do this in grade 3, but later on make a connection back that, you know what, when I square 5, it's not 5 times 2, because 5 squared is a square, and it's impossible for me to multiply 5 by 2 and get a square as an array, right? I would get a rectangle, all right? A square is a very special type of rectangle. So this for me is really important, and as I get into intermediate, when I'm working with perfect squares, rather than me just saying, hey, you know what, I want you to multiply 1 times 1, 2 times 2, 3 times 3, 4 times 4, and I want you to know what these perfect squares are, I would much rather give my students 40 tiles and say, is 40 a perfect square? How do you know? Or why not? And how do you know? And you know what? If I'm in a classroom, I'm just begging for that one student. Might be that, you know, maybe considered to be that smart Alex student, the student who constantly has that smart remark, to just raise their hand and say, hey, sir, I can't make a square with 40 tiles, but are we allowed to break the tiles? And that, for me, would open up an awesome discussion about this idea that we can actually square and square root any numbers we want, including numbers that are going to yield a decimal. So for me, this power of an array is really, really important. So when I look at 6 groups of 6, again, still getting that square, very, very important. So now, when I take a look and think about what we've done so far, okay, I just want to quickly go over this before we continue on. But what we've done, and in our perfect world, unfortunately, we are in a digital world right now, so I can't really give you concrete manipulatives. You may have some at home. I'm going to suggest you're probably not using them if you did, simply because you know, you can visualize this. You've had enough experience to not need that manipulative at this point. But for my students, I want to make sure that they have a concrete manipulative. And over time, they're going to start drawing visuals. They're going to ask that they don't have to do this. Some students will use dots so that it's just, you know, little dots on the page, or they might use X's or, you know, little circles, whatever they want to do to start drawing this visual. And this is going to happen naturally. It's not my choice to say, okay, you need to put the manipulatives away. We want them to have access to them and know that manipulatives aren't just for struggling students. They're for building that conceptual understanding and helping them get towards the symbolic notation. All right, so this is going to be this idea we're going to come back to throughout the evening. Okay, so with that, I also want to address the idea of how overarching the idea of multiplication and unitizing is throughout our curriculum. So I'm going to stick in grade 3 still, and we're going to go to measurement here. And we're going to look at the measurement expectation that you see on the screen. So take a moment, give it a read, and then I'm going to look at something in particular. All right, so you probably noticed there's a lot of stuff in here. I think most of us would probably agree that area is going to be a big idea here. But what is something in this particular problem that maybe we don't give enough attention to? And it comes up in the curriculum quite a bit. Is there anything in there that you see that it's like pasted all over our curriculum? However, we don't necessarily give students a great opportunity to do this thing. Awesome stuff. So everyone's pulling it out right away. This idea of estimating, it comes up first in a lot of expectations, and really it makes sense that it comes up first, because if you've estimated last, then obviously that's not going to be very effective. However, in our textbooks, we don't have a real great opportunity because all of the information is right on the page. So the other piece I really want to focus in on is this idea of measurement, and in this case, area. We also have the word array in there also. That's not the one that I was asking you to respond to. I was talking about estimation, but also this idea of arrays also pops up. So what I'm going to do on the screen is I just went on Google and I just basically Googled water. And now I'm going to call this a pool, and I'm going to ask you, what is the length of this particular pool? And I'm going to have you estimate if I tell you that the width of this pool is 4. All right, we're not going to worry about units right now. That might be 4 feet, 4 meters. I don't know. How long do you think that pool is? All right, we've got 6, we've got 7. Our low of 6, a high of 7. Ooh, it's going to be so close. How crazy is that? All right. What if I show you that? Does that change anything? Oh, we've got 8. Heather's thinking 8. Beautiful. Ooh, we have someone changing the 7. We got lots of 7s here. How about now? Does this change anybody? Changing anybody's prediction at all? Changing your prediction. What do you think? Oh, we have lots of people on 7. We have lots. Oh, there's 6, and you are right. It is definitely 7. The reason why I wanted to include that as well is how easy is it for me to allow students to estimate, as long as I'm not simply saying part A estimate, part B calculate, and here's the numbers. Students are just going to jump straight to the calculation. So not giving them enough information is always a good tip. And then if I wanted to find the area, this brings me back to my number sense, because area is multiplication. Length times width should not be different to a student. They should know that I've already been doing area. They might not know that right away, but over time, I want to be able to actually do some of this. And using tiles, I can actually show the area. And eventually, I can go to a visual where students might see that I don't need to count out individual tiles. But this is going to take some time for students to get to this place. So here's what I want to do. I'm going to turn back to our knowledge hook, and I'm putting up another picture of a pool. I'm going to let you make a prediction on this pool, and then we'll share out those examples right now. So here it is. I'm going to put it up on the webinar as well, just in case your knowledge hook is not working for you, or for whatever reason, if that text box is being pesky. I think it might have something to do with some sort of formatting on certain devices. I'm sure they'll have that fixed up in no time. They are very responsive. All right, we've got some people coming in with their predictions. Feel free to share it in the chat if you cannot participate in the Knowledge Hook game show. If we've got in our chat box 16, we've got lucky 13, 14, another 13. All right, a low of 13 and a high of 16 right now. All right, anybody higher than 16? Anybody higher than 16 out there? Ooh, we've got a couple 20s in there. Did you think I'm hinting at you maybe? Like, oh, he's asking me for it. This is crazy. That's nuts. All right, let's see what we've got here. We've got 12 out of 28 locked in the knowledge hook. I wonder if maybe the text box might be one of the issues there. So I'm going to go ahead and end that question, or give you one more moment here to lock in those last minutes. And ooh, Julie comes in with a late 15. And you know what? What we have here, this is actually, I apologize. For some reason, it's saying that 15 is right on your knowledge hook, but it's actually, check it out, 4, 8, 12. We actually do have 16, so great job to our friends who participated in that particular guy. Awesome stuff, awesome stuff. But now here's the real question I have for you. The real question I have is, can you find a strategy that might allow a student to figure out the area of this pool without simply multiplying 4 by 16? Because my guess is that students, and again, in grade 3, we don't even have an expectation asking us to go up to 2-digit. However, would there be a strategy I might be able to use here in order to find the area using what I already know? Maybe some friendly numbers. I see Paul sharing here, openly saying add 4 perfect squares. I like that terminology there. We see partial products up in there. Awesome stuff. Skip counting by 4s. Very cool. Oh, we have some decomposing numbers. 4 times 10 and then 4 times 6. Awesome stuff. So tons and tons of ways for us to do this. That's awesome. I'm glad that you guys are sharing. So here's an example again. The perfect square idea might be taking those 4 perfect squares. The only negative of using the perfect square is simply the fact that now I've got to add 16s, which may or may not be very fun for a student to do. So maybe going 4 times 5 plus another 4 times 5 plus another 4 times 5 plus another 4 times 1, that might work. But really, it's up to the student. The idea is that as long as the strategy is by the student, they're going to be able to take themselves to the next level and really stretch their thinking. So at this time, before we carry on with the webinar, I want to take a moment just to bring our attention to the spatial reasoning document. Mally's going to share a link for us in the chat window that'll bring you right to the spatial reasoning document online from the ministry. And a lot of what I'm doing in this webinar, but also in all the previous webinars, you'll probably note that for anyone who's been with me anyway, you'll note that there's a lot of visuals that I use. And this idea for spatial thinking really focuses in on this idea of the location and movement of objects, either mentally or physically in space. So spatial reasoning involves the manipulation of concrete manipulatives, but it also involves us being able to do this in our mind. And I'm a firm believer that we can't visualize something in our mind that we haven't had the opportunity to experience in real life. So we really need to give students this opportunity to play with these ideas and then eventually develop these ideas in our mind. Now this is really important because what the research is suggesting is that mathematical success can be better predicted by spatial reasoning than verbal or mathematical skills. So that to me is another big takeaway. So I really want to stress this idea that using a visual doesn't just make the problem more accessible for students because it eliminates maybe the literacy component of it, where if I'm struggling reading now, I'm sort of compounding my issue, but I'm actually accessing their spatial reasoning and their spatial thinking, and I'm actually allowing students to visualize and build that spatial reasoning. So that's really important to me, and I think it's something we need to definitely reflect on. So as we move on further, we're going to hop into grade 4 here. We're going to carry on through this particular progression, and we're going to look at another expectation, noticing that we are dealing with multiplication, but we're not in number sense again. We were just in measurement. We're going to go into patterning and algebra in grade 4. We're going to look at this particular expectation. Take a moment, give it a read, share out anything you notice or wonder in the chat box, and then we will carry on and do a little bit more math, and we'll get some knowledge hook back in as well. Awesome stuff. So we see investigation up there, number talks, the use of distributive property of multiplication. Investigation, inquiry, let students explore and make their own learning, constructing their own learning. I love that. That's great. We see arrays again, interestingly enough. Awesome stuff. And now you might notice that there's also this other guy, and I can't recall who it was in the chat box earlier, who said from area or arrays to area models. So this idea of an area model is now showing up in grade 4, and it's kind of like the older brother of the array, where now we're not drawing out each individual item, we're just sort of using area to represent the items that would be in that spot. So you can, again, sort of see how that accesses your spatial thinking. In this particular problem, and I'll be honest, up until about a year ago, like I was floored when I found out that the distributive property was introduced in grade 4. I would have thought it was much later, coming from the secondary panel. And it's such an important an important property. It's an important tool in our tool belt. The one thing I dislike here in this particular expectation, at the bottom, I know that 9 times 52 equals 9 times 50 plus 9 times 2. That right there, to me, is like, it's a great example of like what we hope students will achieve by the end of the course, which is what our expectations are supposed to tell us. However, that really doesn't give me many strategies. So I really have to pull out the guides to effective instruction or access some other resources in order to see where we might begin. So I'm going to argue here. So again, we're going to look at some arrays, and I'm going to argue that we have an opportunity here with really small numbers to put this into play. So what I'm going to have, I'll show you an example, and then I'm going to give you an opportunity to do this at home and then upload a solution to your Knowledge Hook window. So hopefully we'll get a couple examples that we'll be able to pull in and share with the group on the webinar window. So here's the first one I'm going to share with you. I'm going to have you look at this one for a moment. Feel free to draw it out at home. And I want you to attempt using the distributive property on this particular array in order to create smaller arrays that would make this problem easier to calculate. For a student who doesn't know what 3 groups of 6 is, what might I do? What might that look like? And feel free to just share in the chat box for now, and then we'll do a problem after where you'll have an opportunity to upload your solution. All right, Evelyn's got 3 groups of 2 and 3 groups of 4. Definitely works. Definitely works. All right, we've got, oh, this one's an interesting one as well. We've got 3 groups of 3 plus 3. Awesome, very cool. 3 groups of 5 and 1 more left over. Awesome. So, oh, and 2 more left over. Right on. Awesome stuff here, folks. So we got lots of good thinking going on. Great stuff. One of our examples was by essentially just splitting this array. So while it's awesome to be able to do this in our mind and split these numbers up, composing, decomposing numbers, or decomposing and then recomposing afterwards, we really, again, want students to see what this looks like. So we can split this array into any different arrangements we want. This might be 1, so I saw that 3 groups of 4 plus another 3 groups of 2. You can really see that in this particular case. So really easy to do concretely, and then students can see what that actually looks like. If we look at my visual up here, you can see, and this is the first opportunity, although we don't do it, it would be the first opportunity where we could have used brackets when we use symbolic notation. This doesn't happen in grade 4, but we, as a teacher, should sort of be aware that, you know what, that's what 3 groups of 4 plus 2 in brackets really looks like. And if we can use that idea as we head down into intermediate, towards intermediate, this could be very, very helpful for our students. So here's what I'm going to do for you folks. I'm going to go in and I'm going to very quickly press the next question button on Game Show. And we're going to have you take a look at this particular problem here. Use distributive property to split the array, and we're going to have you attempt to write an expression that represents your expression. So this particular array, 6 groups of 7, we're going to have you actually show this, and we're going to have you try to upload this in Knowledge Hook. So take some time. You might just want to draw this out on a piece of paper If you have a tablet that you're on, that could work too. And I'm starting to think that our, oh, we did get one in from Knowledge Hook, so that's a good sign. Once you enter in your response in Knowledge Hook and press submit, you should see the upload solution button. So that'll give you the opportunity now to click on that button and actually upload an image. So hopefully we get, you know, at least a couple come in here, and then I'll be able to pull them into the slide deck. And Mally, I believe by simply dragging in an image into the slide deck, it'll create a slide, if I recall. So I'm going to give that a shot. And if that's going to make something explode, then hopefully she will let me know. All right, we have some coming up in the chat box here. 3 groups of 2 plus 3 groups of 2 plus 3 groups of 2. That seems like a really manageable way to go about it. We've got 6 groups of 3 plus 6 groups of 4 could work. We have some folks drawing up on the screen. I always forget that you can actually draw on the screen, so that's awesome too. If you want to have some doodle fun up there.
Kyle, you might want to try to put in new page and then drag the image in. Or you might have to go to do the same thing, do a new page, and then load content.
Cool. I will give that a shot. I'm not seeing the indicator, my notification on my screen that anything's been uploaded, so I don't know. Sort of worried that that for whatever reason that text box issue might be a hindrance for us. All right, so we've got lots and lots of responses coming in through the chat. I'm going to end the question on the Knowledge Hook and see what we came up with. Lots of responses there as well. Really creative ways to go about it, and it doesn't look like anything was uploaded, so I unfortunately won't have a sample of yours to share. I'm just going to share a couple opportunities that we have here. So again, if a student really likes working with their 5s and 5's friendly for them, it might look a little bit like this, where we have our 5 groups of 6 or 6 groups of 5 to give us 30. And then we can look at our 6 groups of 2 that we have left over to give us our 12. And symbolically, it's going to look kind of like this. So while in the curriculum it was all symbolic, I think it's really, really powerful for students to be able to see this in their minds and be able to manipulate these problems in such a way. I'll just share one more example of how you could break this up. A lot of people sort of get stuck with this idea that you can only split the array once or that you have to do it horizontally or vertically. You can do both. You just have to make sure that you account for all of the splitting that you've done. So when I split the array twice, once horizontally, once vertically, I've now created 4 partial products, and I really just need to make sure that I account for all 4. Awesome stuff. So what we're going to jump into now is a little bit of using base 10 blocks, because if the numbers get large, you can imagine if I give you something like this, 5 groups of 14, if I'm a student, I'm thinking to myself, man, I'm going to be here for a while, and all I need is for somebody to, bump into my table, and all of a sudden my array's all over the place. So that's a lot of tiles to be working with. What we end up having in most of our math kits in most districts, and I would go as far as to say in every district, since this tool is something that we heavily rely on in the Ontario curriculum, we really get the opportunity to use friendly numbers by splitting at 10, and oftentimes students would naturally split at 10 because we work in a base 10 system. Well, rather than doing this and doing this split with this many tiles, we can actually use base 10 blocks to do some of this heavy lifting. So wherever I see 10 tiles, I could replace that with a 10 rod. Or if I see 100 tiles forming a square, I could be using a hundreds flat. So if we go about it and we actually start building with base 10 blocks, my guess is you don't have any at home. What you could do is you could open up a tab, or on an iPad you might have an app. If you're just on a computer, you might head to this particular link here for the Math Learning Center that has a ton of virtual manipulatives. Or if you want to use individual tiles on the Matthews site, Matthews has individual tiles as well as number pieces, which is a great app that you could be using. So lots of opportunities out there to use digital manipulatives to engage in some of this learning. So because I'm not certain that everyone has base 10 blocks, I'm going to do a little bit of the demonstrating here, and you might just be drawing some of this. So if you've never used base 10 blocks before, I'm just going to take an opportunity just to share with you what this might look like as I build it. I'm going to be using base 10 rods all the way down. You'll notice that it's nice and organized. This array, again, is organized in a very particular order. And then I'm going to be adding on my groups of 4 as well. And in the end, what you end up with is 5 groups of 14. And there you have it. All right, so with that said, I think we're going to take a little bit of a leap to 2-digit by 2-digit multiplication. And again, a little concerned that I'm wondering whether our knowledge check is going to actually allow us to enter in some of the solutions. I would love to see some of the work, but it doesn't seem like this is going to be working out for us. But what I'm going to do up on the screen here is I'm going to give you an opportunity to check out 4 groups of 12. And I'm wondering on your paper if you could do a draw, and maybe somebody out there wants to do a little doodle up on the screen. You're more than welcome to do so as well. And then we're going to start making we're going to start progressing towards the standard algorithm, as well as a couple tricks that we can ultimately use when we start getting to the visual stage of multiplication as well. So I'll give you a moment to grapple with this one, and then we'll share it. All right, so let's take a look here. So this one, once again, using our base 10 blocks, we're really, the way I look at this, and I sort of pictured in my mind, when I look at the factors on the outer edges of this rectangle, I can sort of visualize what this is going to look like, right? You're getting sort of a carbon copy of that 12 up at the top. So it doesn't really get too tough or too difficult when you're doing single digit by 2-digit or vice versa. But when we do get into double digit by double digit, things start to get a little more complex. So here's what I'm going to do for this particular case. We're looking at 13 groups of 14. What I'm going to have you do is definitely give a shot trying to draw what this one looks like, because it is very important to be able to do this in order for us to make a connection to the standard algorithm. So if I take a look at 13 groups of 14, my 2 factors are listed here. I put 13 on the vertical on the left-hand side here, and 14 horizontally up at the top. Doesn't matter which one I put on which side, but you can, in your mind, sort of visualize what that is going to look like. So take a moment, see if you have an opportunity to draw this one out. And I noticed someone had the opportunity to actually share an image on the previous problem. So I'm going to try it on this problem here. If you still have your knowledge hook opened, you should see a question coming down, which is 13 groups of 14. And hopefully we'll have an opportunity for you to type in your result in the text box and press submit, and then there should be an upload solution button there available for you. So give it a sketch. It'd be awesome if we can share out some of your work, some of your visuals, instead of it being so static and only being my visuals as we go. And Mally, I don't know if this is a good time for us to start swapping out some slides, or oh, it looks like someone's drawn, so maybe after they swap out, after they're done this little drawing, we'll have maybe some of those other slides get loaded in.
Yeah. Okay. I'll see what I can do. I'll figure it out.
Merci buckets. Awesome stuff. So we're seeing some drawings up on the screen here, and we're seeing our 4 partial products there. We've got 10 rods by 10 rods is going to give us 100. And we're going to have a series of 10 rods resulting from a 10 rod times a bunch of units. So as we sort of move ahead here through some of the slides, here's my 10 rod times 10 rod will give us 100 squared, since we have 10 squared. My 10 times 4 is going to give me 4 10 rods. 10 times 3 is going to give us 3 10 rods. And finally, 4 groups of 3 for another 12. So lots of opportunity here for students to not only multiply and start to understand why 2-digit by 2-digit makes sense, but also so that they can actually practice some of their math facts. And I think Mally's just updating some of the slides here. We had quite a few, so we'll let her load some of those in. I'm going to, in just a moment, I'm going to hit the end question button, but that still will allow you on Knowledge Hook to upload. You should still see the upload solution button, so I'll press end, and then you should have an opportunity to do some upload solution. I see, very, very cool, I see a sketch here from Paul, which is awesome. So I'm going to drag that to my desktop, and I'm going to try to insert this into our slide deck as is. Get myself a new page, and drag it in. Awesome stuff. So up on your screen, you should see Paul sharing out this particular solution. And again, this came through in the Knowledge Hook browser. So if you see that upload solution button, feel free to take a photo of your work. If you have a webcam, you obviously got to use that. But really useful feature to allow us to see some of our thinking as we go along. I love the Jane. I like the OAME notepad as well. That's great. Awesome, awesome, awesome. So here's Matt's comment. So he's thinking largest square that'll fit in, then left over. Awesome stuff. Very cool. So yeah, if you were, base 10 blocks is kind of that starting point, and then what we want to do is start sort of moving towards using larger numbers, things that we're comfortable with, but as long as we're comfortable with them. That's really important for us to consider. While Mally's getting us going with some slides here, I'm going to toss in a few of our visuals to keep us going. And the next guy that I wanted to share with you was this particular guy, and I'm going to get him up on the screen for you in just a moment. So if I was to look at 12 by 15, which is 180, I'm just going to copy and paste this on the screen while we wait for Mally, because this slide deck balloons out of control very quickly.
Kyle, I'm having difficulty loading it, so you actually might need to share your screen and show the slides that way. So let me just I'll try one more time. It looks like I can only do a few at a time.
Cool. No worries. I'll do a little bit of ad-libbing here for the time being. So up on the screen here, we can see our 12 groups of 15, which is 180. And what I want you to start visualizing is some of the other things that we can do as we start moving towards this visual representation. So we can't, well, I mean, some students stay in the concrete for much longer than others, but over time we're hoping that they're going to be able to move towards more abstract thinking. So as we do that, some students, what they pick up on is this ability for us to use sticks in order to represent the base 10 blocks. So what I mean by this is taking that same representation and using sticks in between the base 10 blocks. And what we see forming here, if I actually eliminate those base 10 blocks for a moment, what I end up getting is a series of sticks, and you may have seen them on the internet at some point, maybe on Facebook at some point. For me, it was really intriguing. I saw this. Has anyone in the chat box seen multiplication represented this way? So Anik is saying yes. And oftentimes when you look at this, some people call it Japanese multiplication, some people call it stick multiplication. Regardless of what it's really called, I don't know if you can still see it, but because I've been doing so much work with base 10 blocks, I can sort of see where the actual base 10 blocks would go. Like this is right here, and I'm just going to use a different color on my screen. But this right here would be my 100 flat. But instead of using the 100 flat, we just focus in on this intersection of lines to represent 100. And as we do this, we sort of progress, and this visual here gives you kind of a nice way of looking at this as well. You can sort of see all the base 10 blocks laid out there. But over time, what you'll end up seeing is you'll see folks doing this and not necessarily knowing why. So what I wanted to do is just take a moment and sort of give you an opportunity to see each of the intersection points and what they represent. So if I pull this guy up here, what I end up seeing is that series of sticks, and each of those intersecting points represent the 100 flat as well as all of the 10 rods, instead of having to actually do all of the work. Now, what I want to make sure I'm really clear, I'm not advocating teaching this particular method unless I've done that base 10 block learning prior. And what would be really cool is if students actually discovered this on their own. If we haven't done the necessary work with the base 10 blocks, then really it just becomes a trick and a trick alone. So that's just one piece that I thought was really useful for us to consider. And the reason why they slant it is essentially for place value. So in order to maintain place value, we have them slanted so we don't get confused as to which intersection or points of intersection represent what place value. So that's where we slant it, and now my 100 flat is way to the left, and my ones are way to the right. But ultimately, it represents the exact same thing. So what I wanted to do is actually start progressing ourselves towards the standard algorithm. So here's the challenge I'm going to give you to do right now. And I'm going to have you start with the following. So we're going to get you to do it two ways. We're going to get you to do, and I'll type it in the chat box here, 22 groups of 26. I'm going to have you use base 10 blocks for that. And I'd also like you to use the standard algorithm to represent that multiplication of those two numbers. So 22 by 26. So what does it look like? And then I want you to try the standard algorithm on a piece of paper as well. And I want you to look at your two models and see if you notice any connections between those two.
I can't get those slides loaded. It's just gone above the amount of data that the program will hold.
Yeah, no problem.
Even though
I'll
I
just
deleted
drag
all
in
the
all the screenshots over here, so I'm just kind of dragging them in. I'll do a new page and drag it in one at a time.
I'm sorry, and
No, that's okay.
sort of a timing thing. You've only got 15 minutes left, or
Yeah,
15
yeah, no
minutes.
problem, no problem. We'll squeeze it.
Sorry about that.
Everybody in the room is all good. They're great people, so they're not at home pulling their hair out. We hope, right?
That's okay. Thanks. Yeah.
It's all good. Thanks. All right, so for those who are still working away, I'm going to, I know that some people, again, when you're working by yourself at home, sometimes it's not super motivating to do all the drawings and so forth. But if you're using Base 10 Blocks, maybe you're using an app like Number Pieces, whichever you've decided to do, basically this is going to be our array using Base 10 Blocks. And I also asked you to consider the standard algorithm. So the standard algorithm, if we actually do the standard algorithm, it's going to look something like this when we go side by side. All right, so here we are, and hopefully you can see both of those on there. And just to reiterate, I want to make sure that everyone knows, like when we're multiplying and using the standard algorithm, typically we start with the ones, and we deal with the 6 times 2. We get 12. We have to carry a 1. Then I go 6 times 2 over here. Some people maybe say it a little differently, which would be awesome if that's the case, because it's actually not a 6 times 2. It's actually a 6 times a 20. And if we start looking at this particular scenario, if we start looking at it and thinking about where the standard algorithm actually fits into this particular image, what we see is the following. And I'm going to zoom through. I was going to share some more representations, but I don't think I'll be able to simply based on time and so forth. But I'll give you the first couple connections here. But for example, if I'm looking at the 132, what you're going to find is that your 132 ends up being the vertical column to the far right. And the reason for that is because if we look up at the top, what you're dealing with is the 6 ones as well as 22. So really, 22 times 6 gives me 132. And what the standard algorithm actually does is it actually takes 2 steps, 2 multiplication problems, and mushes them into 1. And if we look at the 440, the same or a very similar scenario is true, where if I look at 440, in this particular case, what we end up with is 20 times 22. So if we go back to the 10s, when we're dealing on that second row, we usually drop down a 0. We call that a placeholder. Well, the real reason for that is because it's not 2 times 22 or 2 times 2 and 2 times 2. It's really 20 times 22, which gives us 440. So that's a lot of thinking for students to do, especially in grade 5, where this might be extremely difficult. So instead, what we might consider doing is we might consider breaking this down even further before we get to a more formal standard algorithm. Maybe I look at it this way and I think, you know what, let's really focus in on what we're doing. This 6 times 2, this is 6 times 2. I might even write it down and show 12 all on one line. Nobody says that it has to be 2 steps in one line. That's just the most efficient, or I guess the fastest way, but it's also the fastest way to make a mistake if you're not sure what you're doing as a student. The next piece we can do is we can take a look at our next step, which would be taking 6 times 20. Now I'm going to argue students aren't even going to, intuitively, they're going to start with 20 times 20, or 10 times 10 and another 10 times 10 and so on in the upper left corner. But just to kind of keep in conjunction with the standard algorithm we've done, we're showing it this way. But here, now we have 6 times 20, not 6 times 2, and you can see those highlighted out on the grid. And ultimately what we have, and I'm going to skip right ahead to doing all of that work, but we end up in the exact same place. So we end up in the same spot, but with a whole lot more conceptual understanding when we use that base 10 model, and then when we have students try to figure out ways that they can write it out symbolically. All right, now there's some implications of why this is so important and why base 10 blocks are really important, because a lot of teachers, I mean, you might think to yourself, well, you know, like a lot of kids get through doing the standard algorithm and there's no problems, but ultimately what you do when you look at this conceptual algorithm in the middle, what you're doing is what we do in grade 10 academic when we're dealing with quadratics and we're multiplying two binomials, so a binomial by a binomial. That may mean nothing to you right now because it might have been a long time since grade 10, which is completely fine. But just to kind of paint you a picture, eventually students might do it this way. And they might take problems, and they might even take smaller problems and chunk them down to look something like this. So for example, 9 times 12, I can chunk this down using distribution, just like we did with our base 10 blocks, and I can say it's 5 and 4, which is 9, and 10 and 2, which is 12, and I still get these 4 partial products. We now have a visual. I'm not actually, this is an area model where I don't have to actually use all the tools anymore. I'm feeling comfortable with my numbers, with my decomposing and recomposing. And again, this is the place where we can actually write this expression using brackets. And we don't do this very early on, but ultimately what we've done here is we've taken those two numbers and we've decomposed them into 5 plus 4 times 10 plus 2, which is ultimately what we do in grade 10 academic. But in grade 10 academic, the way we often teach it would be like this particular guy, which is unfortunate because there's really not a whole lot of understanding here. Oftentimes in grade 10, we teach this thing, or we call it FOIL. It's simply a trick. It's an acronym. It really doesn't have any meaning behind it to students except for memorization. And I see Paul here shares my my distaste for using FOIL because it really has no meaning. There's no understanding there. The other thing about FOIL that's really crazy, and we do it all the time in math class, is we contradict ourselves when we use these tricks that don't actually work. Oftentimes, teachers will say that when you use BEDMAS, you must simplify in the brackets first, which isn't necessarily true. You can actually handle the brackets however you want, as long as I don't break any rules. And then FOIL tells us to do the exact opposite, which is break down the number and then multiply across. So we just have to be really cautious. And I guess the point I'm trying to make is that if I'm a student and I'm learning some of these big ideas, these big concepts, which would you be able to understand better? If I jump straight to symbolic, or whether I go straight to, or whether I start with a base 10 block model and then move towards a visual representation like this area model we see on the left. Then students might develop their own trick, and they might call it FOIL, or they might call it something else, and that's really cool. I love it when students find their own tricks and they can explain it and then tell me why it works. But I don't want to have to be the one to tell them the trick, because if that's the case, then I'm probably ripping them off of all kinds of conceptual understanding. So that's really, really, really important to me anyway. So what I'm going to do is add a couple more slides here, and I just want to show the implications when we get into grade 9 and into grade 10 before we wrap this thing up. So I probably won't get to show all the ones that I was hoping to. But here's an expectation from grade 9, where we're now asking students to multiply polynomials by monomials with the same variable using, notice, a variety of tools. Algebra tiles, which, if you are unaware, algebra tiles are simply base 10 blocks, but they're not base 10, they're base X. We don't know what X is. In base 10 blocks, we know that everything is a unit, a 10 rod, or a 10 by 10. In algebra tiles, we have a unit, we have X's, or an X squared, just like a 10 or 100 flat is a 10 square, right? So it's the same stuff, it's just looking a little different, and again, we're eliminating some of the stuff that we knew. So let's take a look at what this might look like. If this is a pool problem, and I was to say that, you know what, I measured this pool, I knew that it was 3 meters wide, but I only had a rake to measure the width, it might look kind of like this. And I'm saying I don't know what the length of the rake is, but I used 4 of them to show my, my width. So here I have 4 rakes lined up to represent this particular length. And if I want to actually show this symbolically, that would be a whole lot harder to explain for students. Some students might be able to see, well, if you had 3 groups of 4 x's, that sure, you'd have 4 x's plus 4 x's plus 4 x's. But imagine if I could actually get students to use algebra tiles and show me what the area would be by simply doing the same things that we've been doing since grade 5 with base 10 blocks. So with that in mind, you know, that seems much more simplistic. Again, this might be a little bit abstract for some of you, but I just want to make sure, abstract in the fact that it doesn't apply to your to an elementary curriculum. But I think it's important for us to see that all this stuff that we do, it all connects as long as we're all you know, doing those things. So as I move on in grade 9, I might get a scenario like this, where now I've got a pool, and now I know it's 2 rakes by 3 rakes in dimension. So if I want to find the area of this particular pool, now what I end up with is a bunch of x squareds, 6 of them in total. Because if I picture these as 10 rods, these would be 100 flats, right? If the rake was 10 meters long, then it would be 30 meters by 20 meters, which gives me 600 meters. But unfortunately, the rake could be 5 meters long, it could be 7 meters long, who knows? That sounds like a really long rake, by the way. So yeah, that doesn't sound very realistic. However, that is what we're up against. And ultimately, if I'm just teaching students to do things without actually understanding why, then when we get to really, really complex things, like in grade 10, when we start asking students to multiply those binomials and we just tell them to use FOIL, it's going to be a whole lot harder than asking them to do it if they can picture what that looks like, which might be something like this. Right? So notice how this looks very, very similar, and if I actually overlay the result, which is this guy, right? If I look at that, that looks awfully familiar to that standard algorithm, right? And so it doesn't have to be more complex. It's definitely more abstract because I don't know what X is, but I can still understand how this thing works. So the main idea I'm trying to share with you here, and the main point I'm trying to get across to you, is that as we teach math, and all throughout math, we should be trying to follow some sort of concreteness fading model, but it's an iterative model. So we start with that concrete. Students eventually feel like they're ready to do drawings and visuals, and then finally we get to the symbolic and we start doing things more abstract, right? So that's really, really important for me anyway. Today what we did was we looked at a number of different representations. When we were dealing with smaller values, right, it might have looked like this, starting with those square tiles, going to a visual, right, so drawing those out, whatever that might look like, and then eventually students know that 4x4 equals 16. That's 4 groups of 4, and I know what that looks like in my mind, and that means I'm ready to do that abstraction, right? If I look at a couple other examples here, this might be what it looks like with the base 10 blocks, where I go 2-digit by 2-digit. I go from that concrete to the iconic, so I'm drawing this out, and then finally I'm going to symbolic. Notice that the symbolic here, I'm not showing the standard algorithm, quote unquote. I'm showing an algorithm. This might have been student generated, or maybe it was something we developed in consolidation as a group. Some other students might look at something like this. They might like that Japanese multiplication, and their symbolic might be a strategy using some of their strategic competence that they've built through all of this great work that we've done with concrete representation and visual representations. And then maybe they like that Japanese multiplication, and then their symbolic is some sort of strategy. So for me, and today, the big takeaway I hope you get from this is, again, not only concreteness fading, but the idea that multiplication stretches all the way down from this idea of counting in quantity and stretches all the way up into secondary, and we're all working together as a team to try to help students get to that place where they feel comfortable and confident. So what I want to share with you again, and I share this every session, is this idea of how we began the evening and how I try to begin my classes with that contextual type problem, getting visual, getting concrete, and we move to some inquiry. We get kids actually doing the work, we make those connections, and then we consolidate to move towards procedural fluency. So as we wrap this thing up tonight, we're going to be sharing out all the links later on the OTF website. I just want to thank you so much for joining me this evening. Feel free to visit my website, tapintoteenminds.com, for all of the resources you've seen tonight. They are all up and online and accessible, and you can reach out to me on Twitter. I'm hoping to see you around sometime in an OTF Connect session in the future when we explore division in a similar vein coming up next month. So thanks for having me, and I hope you had an awesome evening, and thanks for taking the time to spend it with us.
Thanks so much, Kyle. That was an awesome session. Really brought made multiplication come to life, and seeing the progression of it and how students can learn and use it. And I hope people had a practical, something practical that they can take back to their class. And thank you so much for being so flexible in the technology. A lot of the times the technology works, but sometimes it doesn't, and I'm not sure why. But you made it work, and thank you so much for being very perseverant in this whole thing. So just a couple of notes from me in the last minute. The first thing is we'd really appreciate your feedback for this session for 3 reasons. One, it will provide some feedback to Kyle, and I know that you had a really informative evening with us. And the second is to provide feedback to OTF Connects and let them know what you're thinking about the sessions. And the third one is providing feedback to the ministry who provides funding for these sessions. So you can get to the feedback form in 3 ways. The first one is by clicking on the very tiny link. I don't know why it's so small. It wouldn't get much bigger for me tonight. That's on the page. The second one is by clicking on the link in the chat. And the third one is when you log out of the session, it will take you directly to the feedback form. And if you could complete that, that would be wonderful. Once you've done that, you